So, thanks for coming. Welcome to Build. My name is Rob Tiffany. I am a children's adventure novel writer. And I have a side gig where I work at Microsoft. And I'm been the enterprise mobility guy for a long time. I think back to some of those videos, we've been doing this thing. Does anybody ever have Windows CE back in the 90s and the Pocket PC and Windows Mobile and then Windows Phone? We have been on a long journey together, a bunch of us have. I made a comment earlier, I was thinking of MEDC 2007 and in Vegas, I can't tell you, I watch these sessions sometimes on YouTube, different big events, and I'll see some authoritative mobile guy say, in 2008, there were 0 mobile apps ever created. Of course, they're talking about the iPhone. It's like, really? I think we had 20,000 by then. Anyway, it's a different world. It's been a roller coaster ride, but it's a lot of fun, absolutely. So today, look at this big mouthful of a title. Wrap a mobile app API around your enterprise, and then we're going to take that data offline with NoSQL, and we're doing it on phones and tablets. That's a whole lot of stuff there. The big takeaway, I guess I'll dissect this stuff, Everybody who's been, you've seen all these API companies. I know you're rolling your eyes. You know what an API is, but now API means something else. It's kind of like the evolution of SOA, of the SOAP and XML stuff that we started doing over a decade ago, and now it's moved on to something else, and it's the hottest thing, and all these API companies are getting acquired by everybody. So I want to talk about APIs, because remember, as an enterprise mobile session here, and what you need to know, and I want to make sure I set expectations properly. Those of you who have been building mobile apps for lots of platforms for consumers, and you think the whole thing is about the app, and all you're doing is programming on the device. Well, my experience is 60–70% of your time when you're building enterprise mobile apps, you're spending it on the server side, actually, and integrating with your customers' backend systems and getting data out to devices. That's where you spend all your time. I had the luck, or I don't know what I'll call it. I get phone calls almost once a month from different folks. I spent a whole lot of time doing Windows Mobile enterprise apps for lots of companies around the world, and a lot of them did the same thing because got them to market fast. They used this little database called SQL CE, and there was this sync technology built in SQL Server that it would automatically sync between the two. And you didn't have to write all that plumbing, like this API stuff I'm going to talk about, or any other thing. It just worked. It was a black box. Lots of companies, more than I realized, implemented that technology all over the world. I still get phone calls all the time because it's like I'm the last guy on earth or something who can talk about that stuff. And I go and help them learn to scale their server side up. So anyway, but in the API space, my street cred for that, I helped to build the API and design it for an energy commodity trading system a long time ago. That just super high throughput, and I remember and this was before .NET came out and XML and SOAP and all that stuff, and I remember implementing it with the first version of .NET to see how the web services would work, and guess what? It was dramatically slower than the lightweight REST. It was even before people knew what the word REST was, but we were just kind of rolling our own, So many of you maybe heard the term Restafarian, maybe? Anyway, I've been a Restafarian for a long time. Okay, so getting that API around a company, because you got all this stuff you need to get out to mobile devices. Everybody's mobilizing their enterprise, right? The other part of the equation is this taking data offline. So I told you I have this background of having mobile databases going back forever, back to 2001, I think, with a SQL CE. That's always been a problem. We don't have ubiquitous wireless networks. So you got to be able to prefetch data and take it offline. If the networks were perfect and fast, and we could do everything with the mobile web, right? Luckily, the mobile web with HTML5 is advancing and helping us there. And then, of course, the last part is I'm going to do something magical and show you a universal app implementing this NoSQL stuff with phones and tablets. This isn't me being prescriptive that you need to use NoSQL. We just want to give you lots of options. You're probably also aware you can use SQLite as well. And that was a big deal for us to make sure we got that working back when we launched Windows 8 and getting it working across platforms. And we have a couple of ways to work with it, either in a LINQ style fashion or more of a classic SQL way of doing things. So let's get after it here. Oh, and I wrote a book last summer about tablet development. If anybody saw any interesting stuff in a keynote where somehow a modern type app was somehow magically talking to SQL CE, anyway, there you go. That's where I like. So, enterprise mobility. This is what you call one of those kind of divider slides that you put in your deck. It had a really cool picture of a Mini Cooper Countryman racing through the countryside. I just put that in there because that's what I have. There's really no significance to it. I just wanted to put it in there. I had to pull it out, though. It's that licensing stuff. So what I want to do, and this will ultimately kind of set the agenda for what we're going to talk about, is I want to talk about what are these ingredients in enterprise mobility. And this is just my view. There's a lot of other things, too. You know, there's stuff I'm not going to talk about, like everybody aware of the device management space, which is a whole other pillar of a mobile strategy. That's where I spend most of my time these days. We have a product. Has anyone heard of a product called Windows Intune? All right, excellent, excellent. I should just start throwing gifts out to you. This is good, this is good. Yes, it's our cloud-based device management product. What's my street cred in being able to talk about device management? I built a device management package back in 2003 and 2004 and sold it. So I was early to the market. I was a startup junkie before Microsoft, and I certainly know, well, you know, the odds are against you, but we get an asset sell. So, first little tidbit, I love this little saying. Just, you know, you hear everybody, even before you started hearing Satya talk about being mobile first and cloud first all at the same time. But I've been hearing lots of people saying mobile first for a while. Sometimes it feels like marketing. My viewpoint is be API first. If you're API first, then everything else works easily. This actually goes back forever. You know, back when I was an entrepreneur and we're talking to VCs and everything, what helps sell your company, your product? Make it a platform. Build APIs, then build your product on top of your APIs, and then it easily extends. So same thing here. Build your API first, that makes it easy to be mobile first. So here's the big thing. So every year, Gartner gives this big, long list of the top priorities for CIOs around the world. And this year, I think mobility is number 2. I forgot what number 1 is. But within that, here it's one sentence. What these CIOs, they want to do. They need to take that data, all that critical business data they use to run their companies, and they need to get it from those systems and get it out to any mobile device. Everybody's trying to mobilize. They want to empower their employees. They want to do that as easy as possible. So that's kind of your touchstone. That's kind of what your reference point. That's the big thing you are trying to accomplish. Yeah, there's a whole lot of other stuff going on, but that's the main thing. Get data from wherever out to wherever. That's it. And do it in a consistent way so you're not building one-off things over and over again. So there's that. So as part of doing that, these got all these back-end systems. I know we read articles, we go to sessions, and everything is about building some cool new app and a new greenfield solution. But the reality in the business world is they've already got all these solutions for the most part, and they've got all these servers and back-end systems they're already using to run their business. And I know you want to build something brand new and it's cool and fun, but more times than not, you need to integrate with what they have and mobilize that and get it out to devices. So you need to, there's lots of ways to do that, and there's a lot of companies over the years. I've spent a lot of time working with Gartner back with the multi-channel access gateway Magic Quadrant, which then turned into the MEAP quadrant, and now it's the MAD-P, and it's just kind of, now you have backend as a service, folks. It's that kind of stuff, right? So you got to do that. But then here's another thing you might need to do. So once you've figured out how to take all those backend systems that don't know how to speak the language of mobile or the internet and figure that out, but then you find out some of these backend systems they built were departmental systems, or they were no way ready for the huge web scale that we talk about. You know, what if you have something that needs to support tens or hundreds of thousands of devices or millions of devices? Most of those systems were not built to sustain that. So I'm going to talk to you about how you can help those systems out. As part, you're going to translate it, and then I'm going to help them scale out. Then the next part is after you've figured out the scale and the translation part, you need to expose that data in a mobile-friendly way. And that's the whole API thing, right? The web API that we have in ASP.NET. And so I'm going to talk about that, exposing that data And I say mobile friendly because every device, let me distill it for you. If it can work from a web browser, from just a plain old web page with JavaScript without needing an SDK, you've hit it right on the head. Because JavaScript, without any extra bits, can call an AJAX, make an AJAX call a REST JSON service, pull it back, deserialize it, and work with it without needing any special bits. So that's kind of where I'm getting at. So it's mobile friendly, because if it works there, you know it's going to work on any device. And it's wireless friendly. I come from the wireless business. And I come from a world where we were doing wireless, where we had to pay by the byte, and we were doing bit encoded packets and stuff like that, and that's what mattered most. And my brain is still living there. And so when I see bloated wire protocols, I know people casually like to talk about wire protocols at cocktail parties, but I do. And that stuff matters. And it may not be as expensive, but it's slow, because remember, someone pushes a button on the device, it goes out to the device with them and maybe 1,500 of their best friends all hitting a cell tower, then going down to a base station, then a backhaul network, out onto the internet, get to the website, get to the web service, whatever you got to hit, go through the outer firewall, through a proxy, through whatever, through a back firewall, queue up on the server, wait and stuff, get the data back, and then make all those hops. That's user experience. Lots of people mistake user experience with UI. A lot of times, user experience is that back-end stuff. If you can make all that lightning fast and scalable, the user will be more delighted when they're using their app. So, publishing those APIs with a mobile access gateway. The reason this is important, you'll start to go, what are you talking about? That sounds really on-premise. The talk I want to talk about today is I want to talk both on-prem and Azure. I know you get a lot of great sessions on Azure, but I checked out the other day, and it turns out almost all my customers are still on-premise. They're thinking about the cloud, they're moving to the cloud, but they all have data centers, and we need to meet our customers where they are today. And we'll get them to Azure, but you need to be able to be flexible. So I'm going to kind of give you a flavor. This whole session is going to be more of something that's going to work more in Azure IaaS and can work on-prem. So you have flexibility. So if you're on-prem, you got to get that data out there, whereas you don't have to worry about it in Azure. It's a lot simpler. Then the last part, which is the second half of this whole session, is then the apps themselves on the device, consuming all those APIs, all that data, working with it offline, and doing transactions and getting all that stuff done. And so this kind of rounds out what this whole session's about. And so if you want to visualize it, this is our problem set that we're trying to solve for in our customers, and this is what they want. If you look across the top, you see all those little circles. They represent different types of back-end systems, It could be Dynamics, it could be SAP, it could be hitting Oracle or DB2 or whatever. Flat files from a mainframe, hitting a Tibco bus, whatever it is. You've got this big chasm here from those, and then down at the bottom here, you see you've got these mobile devices roaming on the internet, tablets and phones and stuff like that. And so the thing we're trying to solve for is getting stuff from there down to here. And that's what we're going to figure out today. I'm going to walk you through every last step of solving this problem here, so you'll have an end-to-end solution. So first part is I need to orchestrate and get all that stuff with the APIs on the background. So this slide had a really cool picture of a symphony with a conductor, but it's gone now. So I've got to mash up all these back-end systems and pull it together. Now, keep in mind, you don't have to do it for all systems. Some systems were built out of the box to have a back-end that talks directly to mobile devices from all kinds of vendors. From Microsoft, it could be LINQ, it could be all kinds of vendors. They've already built a vertical solution. So you don't need to do any translation. You don't need to do any work with them. Hopefully, they're good to go without your help. But about the 90% of the systems out there are going to need some help from you, which is good. It's fun. So first thing I want to say, this kind of goes to being fast and ROI and stuff like that, is with all those different back-end systems you saw, I don't want you writing specific code to each one of those systems to translate that. Lots of people have done it. I've done it. Over the last decade, we've had to roll our own every way possible writing code. But as if you're a consulting firm, if it's your company, you want to do it one way and keep doing it over and over again the exact same way. So you can train once and do it multiple times. So that's kind of what we're looking for here. So lots of ways to skin this cat. A lot of times you might be thinking, oh, you're probably talking about BizTalk. I could be. In this particular scenario, though, I'm going to talk about using SQL Server instead, but you could go the other way, because I'm going to use SQL for some other things that are going to help me out. So that's why I'm bit. The great thing is, does anyone ever do ETL stuff with SSIS on SQL Server? Excellent. I'm such a database guy at heart. I really am, even though I'm a mobile guy. And so the great thing is those SSIS adapters can talk to all kinds of backend systems, and it's kind of this visual drag and drop kind of thing. I have a visual deal, I go from this system to a staging table in SQL Server, that system, and we've abstracted it to make it simple for people to go from one to the other. And again, you only need to do this for systems that need the help, or also part of this kind of helping the scale part, because in addition to translating the way all those backend systems talk, and SQL Server is going to act as a cache that's going to sit in front, like a server facade, sitting in front of those backend systems. And we're going to talk about how you're going to make SQL Server help, bulletproof those backend systems for you. So that's kind of the gist of that. And so let's look at a visualization of what that looks like there. And so, real simple. Same systems across the top there, and then we just have our different adapters, and we pull those data to staging tables. And if you were wondering, do we support all those things? Here's just a quick little sample of things that you can work with from SQL Server SSIS. Those are just kind of a quick smattering of different backend systems, formats, data types, whatever, that you can plug into. So since I have a lot of experience in the MEP space, working with Gartner on that was one of the big things that most MEP vendors would, that's kind of how they would tout how good they are, was we've got this many adapters. We can talk to 10 different backend systems. We're better than the other guy who can only talk to 4 systems, that kind of thing. So that's a big thing. I know this is kind of sometimes seems mundane, but it's work you have to do. Oh, and the cool thing, you see I've got the little, believe it or not, we have the world record for SSIS, for ETL data movement. It's 2 terabytes per hour. So it runs all in memory. And so we got some great performance, we got ease of use. So that's one way of skinning that cat, of getting that data integrated. So scaling out. So now we got data translated, we got it in, but I need to scale out because I'm going to have to help some of these backend systems that are not designed for web scale. This slide had had a picture of a dam with letting water flow through in multiple ways, and it made me feel like a kind of a partitioned system. So let's talk about scaling out. So does anyone know what data sharding is? Heard the term, a few of you? Okay. All right. Think of your favorite social network on the internet today and imagine how in the world are they handling the load of me and 1 billion of my best friends? Well, lots of tricks. We've all gone down that path over the client server days and everything, where we had a database and then we had a web server or a middleware server, and then we load balance the middleware server, but we still hit a single database. But at some point, you would always run out of gas. And if you need to handle 1 billion people, you are scaling in every way possible. And so part of that is being able to scale out the database itself. And so you horizontally, you create this, what's called a shared nothing architecture. In other words, it's all different separate nodes with data replicated or parts of data replicated to each node. And so the web services are hitting things in parallel and not all hitting the same one. That's part of the magic of how all these big systems work. And we absolutely have all that technology to allow you to do that with your Microsoft stuff today. So the gist of it is, if I want to architect for 1 million devices, and I don't feel like, oh, he's telling me to over-architect the system, but you can do this without doing a whole lot of, just if you think I'm building for this, even if I only need to support 500 users, you'll never paint yourself in a corner later on. So I don't want to build a data system that's going to find itself in that quandary where everybody's hitting one system. So SQL Server has some options for you to let you scale out, to horizontally partition. There's a lot of them. Replication, we've got a few different kinds of replication: merge, transactional replication. We have peer-to-peer. We have an always-on technology that lets you have a bunch of read standby systems, things like that. partition views, all kinds of different things that are built into SQL Server too. So there's a lot of options there. But the idea is real simple. I don't want to have a million mobile devices hitting one server. I want to break it up into pieces and have smaller groups of devices hitting lots of different nodes out there, copies. So I'm going to specifically focus on transactional replication sync, which you can use either to have entire copies of databases on other server nodes, or you could have one table per server node, or if you run out of gas there, you can shard within those tables and have parts of tables on different server nodes and have your web services hit those. But luckily, transactional replication allows you to do that. Let me wake up my laptop here real quick so we can actually do a demo in a second. Anyway, transactional replication, one of the things you can do is you can build a bunch of read-only scale-out server nodes real easily with that. That'll pull data down, and that's what we're going to kind of look at. But again, there's a lot of other options. Now here, I'm going to pause for a second and just, I am just totally geeking out, excited about SQL 2014. I think it's such a game-changer product for us. The fact that we're bringing in-memory database to the masses, not some esoteric database that's using some proprietary system, not some add-on that costs a fortune. We're bringing it to the masses. When you all get how much faster things are when you don't have to touch a disk. That's why we started building caching and distributed caching. So SQL 2014, you have these things called memory-optimized tables. Just as I pause here for a second to pimp this, the data is just in RAM. Let's finally take advantage of 64-bit computing, why don't we? And so your tables, you can do it on a table-by-table basis in RAM. And you can have different types of durability. You can have like no durability that says, well, the schema, if the database reboots, it'll rebuild the schema, but not the data. And you can also have one where it'll, on a background thread, write commits back to your real disk, but everything's kept in RAM. How about that value proposition when you go to your boss or to your customer and say, how would you like it if I increased all, because if the database is the heart of our systems, even though we're mobile people, and you say, what if I could increase the performance of the system by 30x or maybe 50x? That's exciting stuff. That's not like, here's a new upgrade with a bunch of little tiny incremental changes. This is game changer. This makes everything you build so much faster and more scalable. So that's the big thing. The other thing is, we also have machine-compiled stored procedures. I'm always amazed. I've found recently, I'll write a blog post about different SQL type stuff, and I have people say, what is all that SQL code you're writing? What is that? And I'm like, what are you talking about? I think a lot of developers today are all using ORM type systems, and so lots of them don't even know about how to write stored procedures or call them or things like that. Well, here's a reason to do it, because our stored procedures now compile to machine code. And so that even gives you even a better boost of performance. It's kind of funny, under the covers, these in-memory tables, SQL Server creates a DLL, is what it really is. And the same with the stored procs, and then they are loaded in memory. And so they're just lightning fast. So speed is your friend, and speed does equate to scalability. Someone can if you got all these people waiting in line, and this guy gets in and gets out faster than the next person can get in. So this is all good stuff, and these are all good reasons to care about this new database. And so the cool thing is, when I talk about this scale-out scenario, transactional replication, the different nodes that are kind of subscribers to the replication publisher, those nodes can use these in-memory tables so that your web services are hitting something that's all sitting in RAM instead of on disk. So anyway, there's my diatribe for the day. And last but not least, if you need to do multi-data center, you've already heard all the great stuff we have with Azure and Traffic Manager and replication there. Here's the equivalent that we have for on-prem, or if you're doing IaaS, is we've got peer-to-peer transactional replication, where it'll just have multiple peers in different data centers in different parts of the world, keeping those things in sync. And so here's kind of our little visualization of what that might look like. And so your primary SQL server that's kind of integrated all that data coming in from those backend systems, and then replication is out to these different nodes that are read-only nodes in many cases, and you can have some for writes. You can have people hit the main database for writes. You can also put writes out onto other systems using our different technologies. And this kind of gives you that parallelism you're looking for. So we're not creating bottlenecks on one box. So this really sounds like a mobile session so far, doesn't it? All right, let me just quickly run through a quick demo here of what I'm kind of talking about. See, there's an emulator. You know it's going to get mobile real soon. So in SQL Server Management Studio, I've just got, for the example for this whole session here, I've just got a simple build 2014 database, customer table. Just to, I'm trying to keep this simple just to kind of illustrate the point. So I've got customers, I've got products, and then we're going to make orders, place orders on the device in an offline mode and post them back up here. Now the magic here is we don't want to have everybody, a million devices hitting this little database here. We need to replicate. So down here on this replication node, you see down, I've created these things called a publication. We have this kind of pub-sub type model. And so what I did here, like we'll just use this customer example. I basically created a publication that says, I'm creating a customer publication just for the customer table, and you can see how easy this is. I'm just checking checkboxes. I'm not writing code or doing anything crazy. And this is how I'm going to create a customer replicated, make this available to go to another node, and I'll have a subscriber subscribe to this. And then likewise, I've got one for products. I also have the option to do filtering. So we have right here in our wizard, you can add filters, which is just like a SQL where clause. These filters is how you can do further sharding if you need to scale out further within a table. So if your customer table needs to be broken apart by last names, different ranges, stuff like that, because you're running out of gas because your system got really popular. Anyway, this is kind of the gist of it, and it gives you that flexibility. And so doing that, then you can see down here, I've got a customer node. Obviously, I have this all in one box, because I'm just doing it here on my laptop. So I have a customer node and a product node. And so, it's replicating down to these nodes. So that's kind of the gist of it. And I don't want anyone to be intimidated by our replication technology. It's very approachable and very easy to work with. All right. I think this divider slide had a bunch of lights shooting or something like that. Anyway, APIs. Let's dig into that. So we got our data, we got the horizontal scale on the database side. Now let's talk about the APIs. Multi-channel transports and data formats. Wow, that sounds really weird. Well, what it really means is that it can work with any device and it can go through any type of server transport. So REST is how the mobile internet is all talking these days. We've been doing the whole SOAP and XML thing for a while, and all the SOA, and we had all the standards bodies and everything. And then somewhere along the way, a whole bunch of different internet companies just said, I don't really care what you guys are working on. We're going to do REST interfaces instead. And guess what? The grassroots thing won and took over the world. And so anyway, there you have it. And any device can communicate with REST services. And somehow along the way, JSON has replaced XML. Not all the time. There's some cases where XML is exactly appropriate, but JSON's smaller than the same thing represented in XML. So that's a great way to serialize data. And then turn on compression on those servers. And so those open, gzip, and deflate is get that compression. So you can see a theme here. It's wireless friendly and it's mobile friendly. We're making the data as small as possible. Then you're going to build an API tier in your server. So you've got all those backend systems and you're getting your scaled out database. Now we need to build this API tier. So most cases, all that translation will happen through SSIS. Sometimes you don't need to do that. Sometimes there's APIs on backend systems that you can call and convert right at your API tier. And then, like I said, sometimes you don't need to do it at all. You're going to pull data from those backend systems, and you're going to hydrate some business objects, some business entities, which is ultimately what's going to go over the air to your devices. So coarse-grained services, lots of stuff, lots of collections of objects, which is kind of like rows in a table, right? You're going to serialize those as JSON because it's smaller. And then the other thing is you're not going to make lots of tiny little chatty calls because that doesn't work with mobile devices. Why? Because you don't know that you always have wireless connectivity, right? So you're going to do lots of prefetching, lots of data sync type stuff. I'm going to prefetch everything I'm going to need, if I can, in advance, and then go out and do my job, like if I'm a delivery driver and I'm on Wi-Fi in the office, or if I'm in France, I'm on Wi-Fi, and then I'm going to pre-sync and get all my data down, and then I'm going to go out and do my stuff. And I'm not going to be trying to make little chatty calls because I may not have connectivity. And then performance, scalability, and availability. So we're going to add some of our cool caching technology because we don't like disks, right? Our SSDs are great, and they got us a lot faster, but we still like RAM better. So do you see a theme here? RAM in memory on SSIS, RAM in memory database tables, RAM in memory, and you're going to see more of it when I get to the client. I want everything in RAM because I'm just a speed freak. The memory cache is just built into .NET, and then of course Azure cache, and then App Fabric caching, all this stuff, App Fabric caching for your on-prem Windows servers. And then of course load balancing, stuff we've done forever, right? So whether you're using our built-in network load balancing on-prem or using an appliance from lots of great manufacturers that are out there, and then Azure takes care of a lot of that stuff for you, so you don't have to think about it as much. So here is the visualization of all those words. So there's your API tier. Well, there's nothing magic there. It's your load-balanced IIS servers, right? And your APIs are being delivered from virtual directories. The cool thing is since we're doing this sharding and stuff, you may never need to do this, but I'm showing you today just in case. All those subscribers, and notice instead of, like if I have the customer table, I don't just have one subscriber customer table shard that I'm going to hit. I'm going to have two that have the exact same data, and I'm going to load balance those two databases, actually, because we need availability too. So in case one of those database servers goes down for some reason. So you can cluster, you can load balance, actually, each one of those read-type databases, just like you do a database, It's just a protocol, right? And so that's the gist of that. Your API tier are calling into all these different shards. And then, of course, they're going to use caching. But seeing is believing. So let's take a look at the web API for real and see what it looks like. All right. So we're going to get rid of SQL Server, and I'm going to pull up Visual Studio. And so I've got my web API. Now, my little helper, since I'm a mobile guy, I'm a mobile guy. I have my favorite mobile device in the world, my Moleskine, and this helps me. So let's see what we're going to do now. We're going to do a demo on APIs. All right, great. Let's take a look here. We're going to look at a lot of different stuff. All right, so let's just kind of look through what we're seeing here. I've got, over here you see, it's using kind of our MVC technology. So I've got controllers, I've got models, I've got something weird called services that I made up. So let's take a look at each of those. So remember the first thing I talked about is we need to serialize that data into those business entities. We need to, so remember the customer table in the database. I'm just building a simple business entity, a model here that looks just like that table in SQL Server that we're going to hit that node. So that's cool. And then there's a controller for this customer object. Now, has anybody played with the web API? Awesome. Have you noticed a lot of examples where you get in the controller and they have you put all the code to do the data access like right there? Well, they're just getting you started. But when you start doing your production stuff, you may not want to do that because you might want to swap your data sources around. You also need to do versioning too. So there's a thing called a repository pattern that I'll just touch on so that you can swap out there. So instead of having all my code to do the stuff here when I call into the controller, I've got a customer repository class that I'm going to instantiate in the constructor, and I'm going to use that to get the data. And so but basically this controller is kind of like helps define that URI, that RESTful UI that you're going to call, and you can do all kinds of crazy stuff with that and routing. And I know there's great sessions here at our event that talk all about that. The repository is where all the magic happens, and so stuff talking to our database, stuff regarding caching, and then stuff related to creating a collection of objects that I'm going to then serialize. But I find the best way to learn things is through debugging. So if I have your permission to hit F10 and F11 a whole bunch of times, I turned up the font even on the tooltips, so if you'll bear with me here, this is my favorite way to learn. So let's just fire this thing up, and we'll bring up IE. This is the great thing about building APIs with our technology. You don't have to already build the client yet. You can build all this stuff and test it with IE, even before you built the device client or anything. So IE comes up here, and let's test. We'll just test one of them. So I'm going to hit API, and I'm going to go to the customer. So this is the URI I'm hitting. And there we go. So we're debugging. And so I'm into the controller, and I want to go in. I'm going to get these customers, and I'm returning a generic, IEnumerable, a generic of type customer. So I'm going to go into this. I'm going to go into my repository class. So I'll F11 in here. And I've kind of got set up my list of customer objects, my generic. And here's where I kind of do the setup for right here, and I'm not using distributed caching. I'm just going to use the simple stuff that's built into .NET here for this example that you can use. So I'm setting up that memory cache. I'm checking, hey, is there anything in that cache yet? And if the answer is no, then I know I need to query the database and get the answer. So there's your standard connection string. I'm going to call in to, wow, I'm calling a stored procedure. When's the last time someone did that? All right, because I care about stored procedures again because they're machine code and I feel the need for speed. All right, so I'm going to call a stored procedure, do the old data reader, our good friend from ADO.NET. But before I start looping around, I've got a customer object, and then I'm going to instantiate my generic list of customer objects because then I'm going to hydrate them as I loop through. And so every time through the loop, I'm going to do a new customer object, and then I've got the ID. Remember, we looked at the class a second ago, and first name, and I'm pulling it back. And sure enough, if I highlight tooltip over this customer, you'll see there's our good friend Andy Wigley. Does everybody know Andy Wigley? He was my co-star. Actually, he did all the work in our giant Windows Phone 8 Jumpstart videos. You might have seen we had like 20 hours. It was grueling. I'm really excited. We've already had over 1 million views. It's totally awesome. It's gone viral. I always wanted to go viral on YouTube, so I'm like Rebecca Black or something. I don't know. Maybe that's not a good thing. So anyway, I won't belabor this, but you loop through, and let's highlight the customer list, and you'll see the collection building up. There's Andy, there's me, there's Nick Randolph from Australia. So we'll go ahead and just blow through this. And you see here at the bottom, since IE will represent XML, but not JSON natively, but there's our answer. Those same 4 that you see from the customer node. That's the most succinct way possible to represent data. Now, the good news is if you like OData, we've done a great job of getting that a lot smaller than it used to be. And so you can absolutely use the OData as well if you want to from the web API. But you know what? Let's do something. Let's see if I can do it in time. I don't know how many seconds have passed. You saw that I had the cache set to 30 seconds. And so the cool thing here is with a cache, it's going to, let me do it again because I didn't step into it. This time it says, customer list was full. It was already in cache, and so things come back in milliseconds, right? So we didn't touch the disk. So speed is your friend. We used to say that. I used to drive submarines, and speed was your friend as far as if you were too heavy and sinking too much. So anyway, a little extra unnecessary trivia there about submarines. All right, let's move along. So if you're on premise, you need a gateway. So I had a cool picture, the cool gateway Moab thing in Utah. That's what was there before. I was debating between that and the Arch in St. Louis. So mobile access gateway. You got to securely publish those APIs from your corporate network or data center or whatever out to the internet where these mobile devices can consume them. So we have something called the Web Application Proxy. If anybody knows Exchange Server, then you've probably used ISA Server and TMG and UAG and all kinds of different edge reverse proxy solutions, or you've used VPNs or whatever to get that data securely out. So guess what? We finally decided to put all that technology into Windows Server 2012 R2. So we have Web Application Proxy. It's built in, which is great stuff. So it's this new remote access server role. So don't have to get a separate product. You just use Windows Server. You put in the DMZ. Or for some of you, it's a DMZ in between the back and front firewall. I don't want to get into it. I know people get religious about how they do their DMZs, so I won't belabor it too much, but you get the gist. It's proxying things in and out. We also work with ADFS, and so that stuff can be claims-based auth, auth, SAML, all that fun stuff, or it can still be the Kerberos that most folks have been working with for years. But ultimately, a reverse proxy, I'm hitting an external, I've got a DNS deal set up, and it hits it, and it translates it to a backend server that's going to hit a virtual IP address, right, and hit a virtual directory. Some other cool thing we have that's great for the IT pro folks really are loving is this idea of workplace join. It's a new technology. A lot of people want to know. So, now we're in this mobile world. We can't always have domain join machines like we've always had, but we still want to know what's going on. And so the great thing is we can register Windows devices, iPads. We're rolling that out to different OSs. So you can do this workplace join. Basically, it registers you, who you are, where you are, what device you're in Active Directory, puts an object in there, puts a cert on your device, creates one of two factors of two-factor authentication, so that it then facilitates single sign-on. And so that's really helpful. It makes it easier for your apps, lots of apps to go hit that once you've done that, and it lets IT know who you are. And also we can do multi-factor authentication when doing that enrollment as well to beef up the security. So those are all good things, and absolutely the IT folks are loving that. And so this is kind of where we are there now. So between that back and front firewall, you're like, oh, you put another virtual direct VIP in there? Yep, because if you have a whole lot of people, you might want to load balance your mobile access gateway. In this case, Windows Server. Or you could be using an appliance or something like that, but you always need to make sure you can scale at every tier, right? All right, now we're at the device part of the session. Yeehaw. I got to keep these pictures. Imagine that, huh? They're ours, okay. All right, phones and tablets. So I've got all these APIs. I need to consume them, download them, talk to them, and then I need to work offline with, in this case, I'm going to show you how to do NoSQL. I'm calling it NoSQL because it's not SQL-C or SQLite. It's not relational. It's table storage, kind of things like that. So for starters, calling those APIs, you're going to use the HTTP client. When we've gone through the past where we've made that a portable class library, but now we have a WinRT version of that that works across all platforms that we have. And so that's what you're going to use to do async calls to these RESTful APIs that you're calling. And I'll show you that in a second. It has built in the ability to decompress automatically stuff, so you don't have to think about it. And then you're going to download these JSON collections coming over the air and deserialize those into real objects, just like the objects you saw us creating on the server side. And then likewise, on the flip side, if you're capturing new data in the field on your device, you're going to do the reverse to send it back up to HQ. Then the other part of this is the NoSQL part. I need to have that offline capability. And in this case, I've got a universal app that I'll use to show you how to do this NoSQL stuff for both phones and tablets, and it's just another option. It's an in-memory object collection, but remember, we have the other LINQ, language integrated query, which lets you query collections of objects like you're doing a database. So that's absolutely what I'm taking advantage of, and in fact, I can serialize that to disk. So you got to keep working, whether the connectivity is there or not. So these in-memory object collections, I can serialize them, I can query them. LINQ gives me all these different operators to have a rich way of talking to them. All your, my ability to prove to you that this is a viable solution is I have to prove that I can do all the CRUD operations against this, so that you can say, okay, all right, that's cool. I could actually use this in my project. That's legit. But to go even further, I need to be able to do something like joins. Because a lot of people think, well, NoSQL, there's no such thing as a joining with NoSQL tables. They're all kind of, there's no referential integrity. There's no, well, I'm going to show you how you can do multi-table joins as well. So to try to bring this home for you to make it look more like a relational database like you're probably accustomed to. And so now here we are, we're on the back end, and we're just out there offline on our devices. And so let's just demo our way home now. All right. So we're going to keep this IE running here because it's going to still work. And we'll be debugging, we'll be looking at stuff, and we'll be debugging through both versions of IE at the same time. So to start out, let's just kind of take a look here on the client. Now, lo and behold, there's our friend, our customer class, our little customer. So if you look down at the structure of a universal app, and I know you saw this in the keynote yesterday, but you've got a Windows 8.1 project here. I've got a Windows Phone 8.1 project. And then I have this shared area with shared code. And that's the whole gist of this. Now, we could have just glommed it all together and just tried to build one thing for everything, but you and I know that different device sizes and types may want to have different views instead of having all the same view. And so, but the guts of the app are all going to live in this shared area. And so if you look here, you see the same model folder that I had on the server. And so there's my customer. And then I've got some other things I'm going to work with locally. So the first one is not the page. I have a NoSQL class. So here, locally, I've created generic lists of customer orders and products. These are our in-memory object collections that serve as our NoSQL tables in this case. And then we'll do a lot of debugging through here in a second. But basically, the gist of this NoSQL class is this is where I have all the functions, all the SQL-like queries that I'm going to be doing against the different in-memory tables. So that's what's going on there. Over here, I've got the table service class. If anyone's ever worked with Azure Table Storage, which is our NoSQL stuff in the cloud, you'll know that you use table service, and you've seen methods like delete table if exists and things like that. So here's where I've got functions to delete tables, to save changes to disk, to isolated storage, local folders on the device so that it's serialized, it's saved, it's committed in database lingo. So saving changes and then loading tables as well, because you want to be able to pull down all that data from your APIs and then serialize it and keep it offline and not have to reconnect. And you could turn off and reboot the device and then be able to reload that data just like you would any database. So it needs to work exactly like that. So that's the table service stuff. And then I've got my API class here. And this is where we're going to make all those calls, the web API I created. And so basically here, and we'll debug through this, but it's designed here to download products, customers, and then ultimately to upload a new order. And so then we'll walk through that and show you how that works. So let's get off to the races here. So what I want to do first is I'm going to start off with the Windows Phone version. So the cool thing, personally, it was great working with universal apps, knowing that the bulk of the code was there, almost nothing. The device, the Windows Phone and my tablet stuff, literally it's just view stuff. And so I built the phone one first, got all that working, and then, less than an hour later, I had the tablet version working. Now, of course, when you see my UI, you'll go, Rob, you are not an artist, and you'll get it. But the gist of it is it's pretty darn simple. So I'm going to set the phone as a startup project, and you see I've got this 8.1 emulator, 1080p, 5.5 inch, which I'm going to barely fit on here. So there's the emulator. Real simple stuff. NoSQL. You can see I've got some list views where I would show customers products, and then all the buttons for the CRUD operations that you expect me to show you to prove this stuff actually works. And then APIs, simple stuff. So on the phone, I'm gonna do the API stuff on the phone, and then I'll do the NoSQL CRUD operations on the tablet. So let's go ahead and start debugging through that. So we're going to download products. So let's start stepping through there. So I'm going into the API class I showed you, and I'm going to use, the first thing I'm going to use is this HTTP client handler. And the reason for that is it does some stuff for me for auth, but it also takes care of things like, does your device support decompression? Yes. And then it's going to go ahead, and remember I talked about gzip and deflate? Well, there you have it. So you need to put that in there so you can handle that stuff if you've got that compression turned on from your server side. Then you instantiate your HTTP client. And then I'm calling that base address, which I'm calling the local web server running on my laptop here. And I'm calling it, in this case, API/product. And then now, boom, I flip to, I'm now debugging on the server side in my other instances of Visual Studio. So I'm calling into the controller. Now, you've already stepped through this code. You've already seen it, but I'm in the repository, so I don't need to belabor that. So I'll go ahead and continue. And now we're back in the client code. And the response got a successful code, so that's always a plus. And then this is kind of where I'm going to deserialize that stream coming down to me, that JSON, and I'm going to turn that into an object collection. And so I've got the data contract JSON serializer, which we beat up on that a long time ago in Windows Phone 7 and stuff, because I know it wasn't fast enough, but it's all good now. But the gist of it here is as I deserialize that, notice I've got, remember I showed you in that NoSQL class, I created the 3 different tables, object collections, generic lists. So now I'm going to highlight over here for products through the clever use of tooltips, and there's some products. There's a motherboard and some RAM. So sure enough, the stuff is actually coming down. And then I have this table service, this thing called save changes, because the offline thing's not real if it's just sitting in memory and then could crash or go away. Oh, wow, this is a lot like SQL 2014, isn't it? So I'm trying to mimic exactly what in-memory tables are doing in SQL 2014. You're working in RAM, and you're saving in the background, or however you want to. You can, think of this as like auto-commit. And you can do it that way, or you can put it on a timer and flush later, things like that. But the save changes, it's basically, I'm taking this object collection, I'm putting it in the local folder, and then I'm just taking it and serializing it, and I'm just writing it as a JSON file, is what I'm doing here. So that's the gist of it. So that worked. The API stuff came down. So now let's close the device. Ooh, look at that. All right. So now let's go to the tablet. So let me get out of the API. Oh, you know what? I closed the wrong one, didn't I? Let me make sure I stop both of them. All right. Make sure this is running on the API side. All right. So back to the app. Now let's go scroll up here. I'm going to right-click on the tablet on the Windows 8.1. I'm going to say set a startup project. And I'm going to go ahead and launch this into the simulator. And so now you can see the different views. So now I'm kind of sideways here. API buttons, instead of being stacked vertically, they're horizontal. And I've got a lot more room for NoSQL. And you can definitely tell I have no career ahead of me as a graphics designer or anything like that. But, it's more of a scratch pad. All right, so let's dive into these NoSQL operations to make it real for you. So first thing I want to do, I'm going to mimic some of the stuff I might have pulled down on the device. So I've got some hard-coded stuff to illustrate. So insert. Let's walk through inserting. So as you can see, I'm going to call into these functions, inserting customers, products, and orders. So I'll just go into one of them, and you can get a sense of how it looks. So I've got locally, I've got customer generic list, which is my in-memory collection, and I'm creating and adding a new customer object and assigning a value to it. And as it turns out, these are the same values that you saw me pull down from the server earlier. I'm going to do that. And then this calling save changes right here is basically saying, yes, I'm going to insert those, and I'm going to auto-commit and make sure. Now we got to see what we inserted. So let's hit select, and I'll step through one of those. So the list view for customer list, its item source is equal to what we're about to look at here. And in this case, it's just the dumbest, super simple LINQ query. It's basically just saying, hey, give me everything you got from the customers. And so I'm going to do that. All right. So now we got our customers, we've got some products, and we have something called bad orders, which I'm sure you're scratching your head about. So there's Andy, there's me, there's Nick Randolph from Australia, there's Martin from the Netherlands, we got our products. And then we have these bad orders. Why are they bad orders? It's because they're unintelligible. These orders are all based on the key values of the tables. So as someone, if I'm working at a store and this is my point of sale, I don't know what those necessarily mean. It's because I haven't done a join to get rich information from multiple tables, but we'll get to that. So it's not enough for me to just do simple CRUD. You've seen me do insert. We've seen selects. I'm going to show you joins in a second. But the other parts are delete and updates, right? But I'm going to show you a range of deletes and updates to make sure you get that we have a full range of features when doing these CRUD operations against these in-memory tables. So the simplest one is I just want to delete one of the objects from there. So let me step into this. So that customer table, me and Andy, and anyway, if you look at the LINQ query here, it's basically saying from this customer list, I'm going to remove whoever happens to be customer ID number 2. Well, that's me. So we do that, we serialize it, and sure enough, now we just have Andy, Nick, and Martin left, and I'm gone. All right, that's what we expected. So now let's do delete many. I want to delete a range of items from there. So let's step into that. And so in this case, my LINQ query is basically saying, hey, wherever the customer ID is greater than 1, well, we know the only one that's 1 is Andy Wigley. So in this case, I would expect it to delete everybody but Andy. So let's see if that worked. And whew, it did. Good. So then the last part of delete is delete everything. This one's mindless. You don't even need LINQ. I'm just going to call the clear method on the object, on the collection. And so that blows everything away, and sure enough, our customers are gone. All right. So now let's do the updates. To do that, let me go ahead and quickly reinsert the data again and select it so we can start fresh and see the same stuff, because we're going to do updates against those. So we're all back to normal again. So update 1. In this case, whatever customer ID is equal to 2, that would be me, we're going to change that person's first name to Mike. So I would expect my name to no longer be Rob, but it's going to be Mike. And sure enough, now I'm Mike Tiffany. Cool. Update many. Do our range. In this case, we're going to loop through everybody who's greater than 1, that's greater than Andy again. We're going to change all their last names to Wyatt. So that's going to loop through. And if everything worked okay, guess what? Everybody's last name is Wyatt, except for Andy. And then, of course, update all. You know, we're going to take care of everybody in this one. And so in this case, I don't even have to use LINQ. I'm just going to do a for each through the collection. I'm going to change everybody's last name to Satter. And sure enough, there we go. All right. So all our CRUD stuff's done. It all works. Now let's do something, a rich multi-table join, which you would typically only expect to see in a relational database. So I want that list to be richer. I don't want to see a bunch of primary keys. I want to see what they mean. So let's step into this join, and we'll just kind of look at it here for a second. Basically, you know, it's on the orders. I'm joining order.customer_ID where it equals customer.customer_ID, and likewise, the product ID and order with the product ID and product. And then I'm going to return something richer. In this case, I'll still return the number, the product ID, the order ID rather, but then I'll return something richer like first names and last names and things you might expect so that it's friendlier. And now, sure enough, we have good orders. So now we have order number 1, and it's Andy Satter in this case, and he ordered a motherboard, and he had a quantity of 1. And in this case, we have other things here. So there you've got rich joins, and so hopefully that section there, you know, you get the gist that this is a good option for you in addition to things like SQLite or other types of serialization. So let's finish this off by doing a round trip. We did create an order there, so let's upload that order back to our web server, back to our web API. So let's check for our collection, and yep, sure enough, we got more than 1 order that we placed. And so I'm going to call into this, upload order. I'm going to pass in the first order in this case. Let's do the tooltips. There you go. That's what it is. Those are all the primary keys for it. I'm going to use the same HTTP client. I'm going to serialize that string as JSON so you can see what the JSON looks like. And then we're going to go through, and this is how, now I'm back on the server side on the API call, and sure enough, the object passed through, looks exactly like what we created. I'm going to step in and do an insert, as you might imagine. In this case, I'm going to do this directly into SQL Server, but you may choose to drop this in a queue. You may also choose to update a distributed cache in this scenario as well. And then I'm calling the store procedure to do the insert into this with all the nice parameters and just execute a non-query. And now we're back on the client. It worked. Seeing is believing, so let's go back up here. Look at our order table. There's the order we just put in at 155, or at least on this device. And there you have it. So we have totally done the round trip. showed you how to take that data, scale it out, expose it with an API, pull it down, take it offline with phones and tablets in the same solution, and look what you built. You built this thing. It's overwhelming all at once. That's why I kind of gradually built it out for you. But yeah, this is exactly what you built. And again, this isn't meant to intimidate you. That's why I went slowly. But what I want to get across is being an enterprise mobile developer is a very, very different thing than being a consumer mobile developer. Well, I appreciate you coming, and I really thanks for your time. I think we're right at the 2 o'clock, but you will be able to come find me afterwards, and I'd be happy to answer whatever questions you may have. And please fill out an eval form. Thanks so much for coming.